Roel, what's the biggest changes in Wi-Fi? I mean, we want to get into the weeds and the details, but like just off the top of your head, what are you excited about in this new release of Wi-Fi?
Yeah, I mean the most exciting thing for me is OFDMA,
Yep.
which is multiple access, BSS coloring, and also target wake time.
So those are like your top three things, yeah? So, but do you have like just like a quick overview of what each of those actually are?
Yeah, OFDMA is borrowed from cellular technologies where it allows multiple access onto the channel. So you're subdividing a channel into multiple subchannels. And then you got BSS coloring, which helps in high density situations where if you're on the same channel, you can tell if another transmission is coming from a different network or BSS basic service set. And then target wake time is really meant for power saving. It's a better power saving mechanism where it's a scheduled wake for clients, and it's catered towards IoT and mobile devices.
So, assuming, well, that you had a perfect, pristine environment. So you had your Samsung phone just at home. You've got one AP. There's no interference. What is the speed theoretically that you should get?
Theoretically, you'll probably get over 1 gigabit per second, right? So, assuming your access point is connected to a 1 gig port, and and you've got the bandwidth wherever you're at, you do a speed test. Everyone goes to speedtest.net. You
Yeah.
could probably get close to a gig or even over a gig, as long as that device's capabilities can go over a gig. Right, you're going to need a little bit more radio chains. You're going to need to support um, more channel widths, right? You have to support 80 and 160 megahertz channel widths. That's how you're going to get more throughput, is by using more channel widths, channel bonding up to 160 megahertz, and then having more radio chains. That's to transmit more data. So the more data you can transmit, the more throughput you can get.
So I just wanted to say for everyone who didn't understand half the terms that Roel was talking about, we're going to talk about those terms in this video. So don't worry too much about that, but I just wanted to have that in the beginning to put him on the spot about how fast it will actually be. Because I believe it's supposed to be, in theory, 4 times as fast or 5 times as fast as AC. Is that right?
That's what they claim.
I like that. I like the way you said that.
That's what they claim, and possibly in a lab environment, that's how it works. But in the lab environment, how are they testing it? Right? Is it one device, or is it 10 devices, or is it 200 devices? Because if it's 200 devices, I don't know if I can't see everyone getting over a gig speed just because of
Yeah, I
how
mean,
Wi-Fi works.
yeah, and I mean, apart from the fact that some APs, like we were given these Cisco APs, they only have a 2.5 gig uplink. So, I mean, if you have 200 devices, I mean, you still got to share that uplink speed.
Yeah, exactly. So you're always going to be limited by upstream and whatever port you're connected to, and also ultimately what your bandwidth is leaving your building.
Yeah, I mean, yeah, I mean, I've only got like 60 megabits per second at home on my internet connection. It's not really going to help me having a gig
And not to
there.
mention at a lot of events, or if you go to a conference, there's a lot of people that still like to throttle users. So
Yeah.
even though we may have Wi-Fi 6 capability, and everything's Wi-Fi 6, there's still a lot of venues that are probably going to throttle your bandwidth down to less than 10 megs.
Yeah, that's a good point. Just for everyone's benefit, I asked Roel just to give us a quick overview, as an introduction to this video. And now I'm going to cut back to like our original deep conversation about, what Wi-Fi is about.
Wanna shake the ground, wanna break away, let loose. I'm tired of waiting, gotta make that move.
Hey everyone, it's David Bombal coming to you from the UK. Really excited to be talking to someone who knows a lot more about Wi-Fi 6 and wireless technologies than I do. Roel, welcome to the show.
Yeah, thanks for having me.
So before we get started, I met you at a Cisco event in San Jose
Yeah.
just recently, a few weeks ago. It's really good to meet you. And I mean, I know that you and a buddy of yours have a special podcast. So just before we jump into the technical details, if you want to know more information about wireless or Wi-Fi. Roel, tell us about the podcast like very quickly, and then I'll start hammering you with questions about Wi-Fi 6.
Yeah, sure. The podcast I started back in 2015, and then I added Francois, my co-host, because it was for me got a little boring talking to my wall.
Talking to yourself.
Yeah. So it's a little
Exactly.
bit more of a lively conversation. So we've been doing the podcast. We try to publish every week, and we talk primarily about Wi-Fi topics. So we do technical and a little bit some of the non-technical discussions around wireless technologies. And we recently did a Wi-Fi 6 series where we took the draft of the 802.11ax or Wi-Fi 6 as we're calling it now, and we just talked about it on the show.
Yeah, I mean, if you can give me those links, I'll put them below for anyone who wants to, go and get more detail. But I mean, the aim of this call is firstly to introduce you to my audience, so they get to know you as someone who's an expert in this field, but also to like try and get some explanations of Wi-Fi 6 in, I would say, someone who's sort of new to wireless, who's watching this can understand it. So I'm going to try and get you to answer the questions as simply as possible. But before we go there, I mean, let's talk about your experience. You obviously have a lot of experience in this area. So I don't want to give it away. You tell the audience, where do you work? One of the places, should I say?
One of the
It's
places.
quite a small campus, I believe.
Yeah, it's a pretty small campus on the West Coast. I am
Right.
a network engineer for Stanford University, and all that really means is I do a lot of layer 2 switching and a lot of wireless. And so the campus is pretty big, and I'm going around trying to redesign a lot of areas for how wireless is used now versus how it was before when it was just about coverage. And so that's a very unique environment with a lot of different demands and requirements that people want, especially when it comes to lecture halls. So that's my background. I do have a networking background. Actually, I started off in systems administration, dealing with servers and Microsoft servers and mail servers, and I'm glad I don't have to do that anymore. But and
So do I.
and when I do have time, I actually do a lot of wireless for other companies in the Bay Area and some select companies that are not in California. But I do help others with wireless design, configuration, troubleshooting. And so that's on top of doing my day job and the podcast.
Yes, I mean, you're really busy, obviously. I mean, just for everyone's benefit, you wake up at 4:45. I mean, what's the time now at the moment in California?
Right now, it is 5:45 a.m.
Yeah, so really early. So thanks very much for waking up so early to talk to me. So let's talk about Stanford. I mean, how many students are there on the campus, or how many do you have to support, kind of thing?
There's a lot. There's over, I believe, over 10,000 students that are on campus, I believe.
Yeah, so you got 10,000 students, but you've also got like
You got faculty,
staff and
faculty,
go on.
staff, and that's over, I think altogether, that's over 12,000 to support everyone. And so for wireless, we do wireless for the camp. I'm not the only wireless guy. I mean, we have other network engineers,
Sure.
but there are some of us who focus more on the wireless side, and we have to support all of those people and all the different applications they want to use. So it can get pretty demanding at times, especially when there's events coming and people want to do some pop-up events where there's no Wi-Fi there. It's just a tent, maybe.
Wow.
So we have to work with some unique environments, and especially dealing with a campus that's got architecture that nobody wants to modify. It can get challenging.
I'm just going to make a joke now. I mean, university students, a lot of people have this perception that they're not the most user-friendly type of people to support.
Yeah, higher education is in that niche. I would just say there can be some pains. We go through that sometimes. I think that's on par for any university, but we try our best. I mean, we want Wi-Fi to work. We don't want to have the stigma of we don't want to make it work.
Yeah, I mean, people, and I mean, I'm assuming, I mean, it's a trend. Younger people, university students, are extremely demanding. When they think of the internet, I think a lot of people think Wi-Fi is the internet. That's how they get onto the internet. I mean, MacBooks today, iPads, iPhones, all these devices don't have physical connections. So what are your thoughts on this sort of trend away from physical networks to wireless, and how is Wi-Fi 6 kind of making you excited for, supporting your user base?
I mean, it's great, right? Because we don't have to stick to a single desk, right? So
Yeah.
we can move. I do this at work. Sometimes I don't want to sit at my desk. I will go somewhere else and sit maybe at one of the cafes on campus, or an area that's kind of have like peace and quiet where no one can just walk up to me. And I do that wirelessly. Same with any other student that wants to work, say, on the grass during the summer. They'll want wireless there. I mean, there's sometimes where we can't provide that because in order to provide wireless, you got to have a cable going to the access point, and
Yeah.
sometimes that requires trenching, digging holes or digging the ground to run cabling to access points. Um, what I see where Wi-Fi 6 comes into play, because Wi-Fi 6 really deals with high efficiency. That's the name that they've given it, right? With AC, we had very high throughput. And so now we're trying to make Wi-Fi more efficient with what we have. And I think when all our devices are Wi-Fi 6, that's when we're going to see a lot of the benefits of Wi-Fi. And because of that high efficiency, then will lead to better throughput, lower latency, and it'll be a much more pleasant experience when it comes to high density type environments, right? Your lecture halls, your events, even your dorms. That could potentially increase your user experience.
Yeah, I mean, it's interesting that you said we started off talking about like Wi-Fi 6, and then you said 802.11 AC. So I'm going to start with the basics. Why is it called Wi-Fi 6 rather than some other acronym, or is it called by some name?
There's so many acronyms, I think, that we needed to make something a little bit more simpler, especially for people who don't work who are not in the trenches of wireless, right? I call it 802.11ax. I called it 802.11 AC. Those are the actual names, the standard names that IEEE has came up with. But the normal student, faculty, staff, they have no idea what that is, right? It's just Wi-Fi. And to them, calling it Wi-Fi 6, they know like that's the latest standard, Wi-Fi 6. And they know that if they see the Wi-Fi 6 sticker, then they're buying the latest equipment with the latest technology, right? That term came out of the Wi-Fi Alliance, whose job is to integrate these technologies with society and make sure it gets marketed properly out there. And I think it's a good name, right, for the average person, because no one's gonna know when I say 802.11ax. What the heck is that, right? So Wi-Fi 6 makes sense, and then if you go backwards, right, Wi-Fi 5 is 802.11ac and so forth.
Yeah, I mean, I think it makes a lot of sense. When I look at the names, IEEE names like 802.11a, and then we got B, and we got G, and we got N, and Wave 2. I mean, it's ridiculous. How is a normal person, and when I say a normal person, a non-technical person,
Untechnical, yeah.
going to understand like what that actually means? Like, I mean, is A better than G? Is A better than N? I mean, it doesn't. There's no sort of logic unless you're a technical person.
Right,
So,
you wouldn't know. And IEEE works that way in sequence with the letters, right? And the reason why they're on AX is because the single letters have already been taken up. We don't necessarily hear about all of them, and some of those letters are very specific to different things.
yes, I mean, it's not just Wi-Fi. It's other things as well, yeah?
Yeah. Yeah, Wi-Fi 6 encompasses a lot of different standards and amendments that have been created, right? You got 802.11i. Nobody knows what that is, but that's security for Wi-Fi. That's your PSK, your pre-shared key that you type into your wireless network.
It's a very good point, that. So I'm glad you've raised that. So let's get to the very important question. How fast or how quick, because that's all we care about, speed, throughput. No, I'm just kidding. How quick is Wi-Fi 6 compared to Wi-Fi 5? Like in theory, and I don't know if you've had any practical experience deploying it yet. Like, what is your experience?
In theory, it should increase your throughput, but a lot of that is going to be dependent on your environment, because Wi-Fi in general uses what's called unlicensed frequency. That means anyone can develop a piece of equipment that can work on the same frequency as Wi-Fi. So that could be cordless phones, that could be wireless cameras, and everyone that creates this equipment interprets these standards very differently. So sometimes these equipment can maybe not work properly over Wi-Fi, which could effectively lower your speed, right? Your throughput and your speeds. And I've seen this all the time on campus where even an Apple TV, and this is not to harp on Apple, this is just maybe
A lot of people use Apple.
a lot of people use Apple. It's just sometimes drivers, right? Like
Yeah.
we talk about drivers and firmware, sometimes they don't work the way they should. And I've seen an Apple TV just kind of slow down the network for everyone in the surrounding area. But when we replaced it, it was fine. And so when it comes to throughput, Wi-Fi 6 is really aimed towards efficiency, and just remember it's high efficiency. So we're not really aiming towards increasing throughputs dramatically. I think as a byproduct of the efficiency, we're going to see throughput increase.
Yeah.
But that said, I don't think we're going to see this until all the devices on the network are Wi-Fi 6.
I mean, you've said that a few times now, high efficiency, it's efficiency. So can you explain what that actually means? So, I mean, if I'm in the middle of the desert and I've got a little Wi-Fi AP by my side, it doesn't sound like it's going to make a lot of difference. But in your environment with a whole bunch of students roaming around, it sounds like it'll make a difference. So could you explain that in more detail? And let's go a bit technical.
Yeah. So if we go back to what we're using now, which is AC or Wi-Fi 5,
Yeah.
that was called very high throughput. That means that we had better or increased channel bonding, right? So if you think in 20 megahertz, 40 megahertz, 80 megahertz, 160 megahertz, the more channels you add, right, you're widening your lane so you can push more data. That increases your throughput. Now we're not increasing any channels in Wi-Fi 6. What we're doing is making better use of those channels. So if you think in terms of like a single lane highway and you've got a single car going through, it's like a single transmission. When a device wants to talk or transmit, it's going to send data, but it's like one device at a time. A single transmission, doesn't matter how much data it's going to push, it's just a single transmission going through, right? And you've driven on a highway, you've seen cars or you've been behind a car that's maybe too slow, right?
Yep.
You're driving your Ferrari and
I wish.
there's a little, I don't know, Pinto in front of you, and it's just not moving as fast as you can, right? That's very similar to Wi-Fi, where you've got devices that may be slower, that have the legacy protocols, maybe your 802.11b or G or N, and then you've got your latest, your 802.11ac. That's your Ferrari. You're driving behind, you're transmitting behind somebody that's maybe too slow. So you have to wait for that device to transmit, get off, and then you can get on. You might transmit faster because you've got faster speeds, more spatial streams, more radios. Your 2x2s, 3x3s, 4x4.
I'm gonna ask you about all of those terms in a moment, but carry on.
But with 802.11 AX or Wi-Fi 6, they introduce. So let me back up a little bit. That term that I've just discussed right there is called OFDM, orthogonal frequency division multiplexing.
Yeah.
With Wi-Fi 6, they introduced a technology that they're borrowing or using from cellular technologies called OFDMA, and that's orthogonal frequency division multiple access. And what that means is that they're taking that single lane highway or that single channel, and they're dividing that up into smaller channels so multiple transmissions can go out at the same time. So if you take that single lane highway, and Cisco has done a great job at this analogy for this, and what they've done is instead of that single car, or maybe let's use a truck as an example, like a big rig, and you're only sending very little data. Like a lot of data that we send are very small packets of data. And so that's inefficient in Wi-Fi if you're just sending very small packets, one transmission at a time. With Wi-Fi 6, you take a truck and you just fill that truck with large amounts of data, and you divvy that up, and that's different clients that you could transmit to, or a client or multiple clients can transmit on that same channel at the same time, but divvying up that channel into smaller channels so every client is allocated a specific channel or a specific length of a channel. And at least now in a single transmit, or what we call a transmit opportunity, TXOP, we can send multiple transmissions there. And so that's making better use of that single channel and taking advantage of a lot of transmissions that are smaller packet sizes or frame sizes, the payloads. And then just with that efficiency, we should see throughput increase theoretically because of that. And that's kind of the gist of it. I'll send you a link, David, of the Cisco video that really kills it on the analogy, because it's really good. It
Rob
really
Boyle, right?
helps people understand what we're talking about when it comes to Wi-Fi 6, because I think Wi-Fi 6 is the most complex protocol right now for wireless. It's a lot to understand, and there's so many things that nobody has spoken about.
But that's why I'm talking to you, because you're going to talk about it.
I'll try my best.
No, of course. I'm putting you on the spot. So, I mean, just for everyone's benefit, I warned Roel that on this call I'm going to poke him, because I want to try and get to the nitty-gritty and try and get a good understanding of how all of this works. So, Roel, hopefully we'll get through all of it during this call, but, just let me know if I'm poking too hard. So, let's go back, because you mentioned a whole bunch of terms there. So let's start right at the beginning. In Wi-Fi, we have these things called channels. So as an analogy, is that kind of like a radio channel where I'm like in my car driving and then I go to a certain frequency and then I get a radio station? Is that what you're talking about?
That is exactly it, right? A channel in Wi-Fi terms is really a range of frequencies. So in 2.4 gigahertz, there's 14 channels in the US, but we like to use 3 channels because they're what we call non-overlapping. And I don't know if you guys recall ever being in the car listening to radio and then you hear 2 radio stations at the same time, right? That's similar to having channel access points operating on the same channel in the same area. And so it's hard to understand what's going on when you have access points on the same channel, providing service in the same area for a bunch of devices. And think of Wi-Fi as a like standard radio, like a two-way radio where you have to speak, you have to wait for the other person to respond. But if you guys try to talk at the same time, nothing happens because no one understood each other, or that transmission failed because you can't speak at the same time. That's how Wi-Fi works. It's really like one user or one device transmitting at a time, but it happens very quickly.
Yes, I mean, this is that going back to the analogies. I just want to give people, the foundation, and then we can come back to this OFDMA. Is that right?
Yeah, that's correct.
And MIMO thingamajig. So we still need to get to that. But let's start with the basics. Okay, so we've got a channel which is kind of like 20 megahertz is the size of a channel.
Starting at 20 megahertz, yeah.
Okay, so that's like a radio station broadcasting on a specific channel. In Ethernet, we have carrier sense multiple access collision detection. And I think what you've just explained is this carrier sense multiple access collision avoidance, so CSMA/CA, yeah? Is that right?
That's correct.
Now, I've heard some hype that Wi-Fi, and I'm going to not mention names, but Wi-Fi used to be like a hub, but now in this new version, it's like a switch type thing. And I've read that actually in some technical books, because it sounds like what you've said is in this new version of Wi-Fi, rather than like a 20 megahertz, sorry, is megahertz, is that right? 20 megahertz channel, and only one person being able to speak on that channel, like with your two-way radio analogy. Now that channel is split up into sub-channels where traffic from multiple people can be sent at the same time. Is that correct?
It is correct, and I still think using the term switch is still incorrect in a way, and I think the reason why vendors like to use the word switch or switch-like is because of the theoretical speeds that you can get out of Wi-Fi 6 and even in Wi-Fi 5, getting over a gig, right?
Yeah.
They always mention over a gig, so they're saying it's switch-like because in a switch we're used to 1 gig ports. I think it's getting closer to being like a switch, but it's still technically not. It's still half duplex. Wi-Fi is still a half duplex medium. So yeah, we're dealing with collision avoidance. And whenever there is a collision, in Wi-Fi, you have to back off what's termed as, okay, I sense a collision because I did not get a acknowledgement of my frame from the recipient. So I'm going to wait because I think there's something going on, and it's a random timer, and that's what actually slows down your throughput. Is if you have a lot of collisions, the wait time starts to increase. That window starts increasing as you have more collisions. But I still think switch-like is an improper term.
Sorry, I interrupted you there. So you're saying it still acts like a hub,
Hmm.
even in Wi-Fi 6.
Yep. It's because we're subdividing the channels, and when you subdivide those channels, it's still a very specific frequency. So a device will lock on to that specific frequency, and only that device should be using that frequency. And that's why I
So
say Wi-Fi 6 will be better when all the devices are using all Wi-Fi 6.
So when you mentioned about channels, and I'm sorry to hop on this, I just want to try and get through some of these terms, and then we can take it to Wi-Fi 6. We had a single channel, and then you mentioned in AC, I think, that they do this thing called channel bonding or something. Can you explain that?
Yeah, so channel bonding is very common in the 5 gigahertz frequency. And so in 5 gigahertz, you have multiple channels, 20 megahertz channels, I think about 24, 25. And so the most common, the first one is channel 36, and then your next channel is channel 40. If you bond those two together, channel 36 and 40, put them together, you now have a 40 megahertz wide channel, and you have a channel big enough to hold more data, so your throughput goes higher.
So is that the analogy like I had a single lane and now I've got 2 lanes on a highway or something? Is
Yeah,
that
that's
right?
correct. Yeah, you doubled your lanes, right? So if you look at traffic as an example, single lane, all that traffic behind in that single lane, it's slow. But if you open up a lane, you ever notice how some cars just start going to the second lane? Now it speeds up. There's more cars going down the road. That's a good analogy. Yeah.
So I mean, the AC didn't actually increase the speed of like a single channel, or did it do that in addition to increasing the speed by giving us more channels?
Yeah, it gave us the 160 megahertz channel width, which I personally don't use anywhere. And there's a number of reasons why, which we can dig into.
Yeah, so I mean, the way, just trying to understand this, the way that the speed increased is because we've got more lanes, and then
Yeah.
we can bond that and send more data by
Mhm.
using multiple lanes from the access point down to a client. Yeah.
That's correct.
So can you explain MIMO, or how do you pronounce it, MIMO? And I believe there was a difference between AC and AX now. That's quite a big change.
Yeah, so there's MIMO was introduced, I think, back in 802.11n, and that's multiple input, multiple output, and that's just meant to the best way to explain this is to speed up the medium by using multiple radios on your access point or your devices, and being able to transmit again more data. We're just trying to transmit more data as fast as we can with without breaking the law of physics.
Yeah, I saw you had an interview, and you were talking about this issue about the law of physics, and it seems like this is a major issue for a lot of wireless deployments. Is this, you can't bend physics, and you have to, you'd love to go faster, but physics doesn't allow you, type thing. Is that right?
Right, and a lot of it is also because of the unlicensed frequency that we use. Right, if you have a licensed frequency, which our devices can't use that because it has to be tuned to that frequency, then I mean that frequency is all yours. It's a lot cleaner. You can do potentially like full duplex wireless technologies, and that's actually capable. That's out there, but we see that a lot with point-to-point transmissions.
Explain this thing about the multiple antennas, because I see like Netgear and some of these vendors have like a whole bunch of antennas on their AP. So how does it work with these antennas? How does it work practically to send more data? Do the antennas work on different frequencies, or how does it work?
Yeah, so there's a set of radios that will work on 2.4 gigahertz and a set of radios that will work on 5 gigahertz. And then you'll have multiple what's called radio chains, right? You'll see like 2 by 2,
Yeah.
3 by 3, 4 by 4. All that really means is you got two transmit and 2 receive, 3 transmit, 3 receive. And so what that means is you can use that number of radios to transmit data. And the reason why more antennas is usually good is because you can now use like antenna diversity. So maybe one antenna can hear a transmission better than another radio. And so there's these algorithms that these vendors use to try to take advantage of that through one antenna. And then there's a lot of what we call reflections, because signal bounces around everywhere.
Yeah.
and maybe another antenna can hear some of that transmission. And so what it'll try to do is combine those signals internally and try to basically boost that received signal so it can what's called demodulate that signal, take that signal in the air and make it digital and make it understandable.
I think that's really important. Sorry, I interrupted you. Carry on.
No, I'm saying that's basically why we have more antennas on access points. Is that also helps increase your speed, your throughput on your wireless network. You can send more data that way, and the signal is more resilient with multiple antennas because now you got more ears listening and more mouths talking.
I think it's a really important point that you raised. I mean, the whole idea here is we're taking a digital stream of zeros and ones, and then we modulating it into waves on the air, and then somehow trying to demodulate that on the other side back into zeros and ones. So, I mean, I liked your analogy of the radio stations, because if there's a lot of noise from other devices communicating, it becomes difficult to demodulate that. So, pushing you on this now. So, if I've got, you call it radio chaining. If I've got like 2x2 type thing, where I've got 2 transmitting and 2 receiving, they still use, in the traditional sense, only one channel. Is that right? Or do they split channels, use multiple channels? How does it work?
Yeah, it's based on whatever channel you've configured your access point to use. That's what those radio chains will use, the operating channel that's configured. So whether that's 20 megahertz wide or 40, it's going to use whatever channel you've configured to use it for.
So I know in Wi-Fi 6 they suddenly have increased this. So can you just talk around that? And I don't want to try and mention the values because I'll get it wrong. But I know in AAC it went higher, and then AX it went higher again.
About the channels?
Yeah, so or the radio chaining, is it 8x8x8 or something?
Yeah, so they've increased that in Wi-Fi 6 to 8x8, which there aren't many access points right now that are 8x8. And that's just a lot more radio chains because of how complex Wi-Fi is now with Wi-Fi 6 and all the sub-channels you have. You're going to want a lot of antennas to be able to grab that signal and also to be able to send that signal. And also a lot of that depends on another term, MU-MIMO, which we can get into also.
Yeah, let's talk about that. I mean, so firstly, I mean, what you're saying is 8x8 means 8 transmit, 8 receive type setup.
Yep.
Is that right?
That's correct.
And that's greater than AC, which was 4x4. Is that right?
Yeah.
So, I mean, they basically allowed you to add more radios to get better throughput. Based on like what you said, more ears and more mouths, I suppose, is the analogy.
Yeah, and it's not just for the access points, it's for the devices too. The limiting factor for that, though, is the reason why you don't see an 8x8 phone is because that would probably drain your battery, within minutes because of how many electronics have to be powered up in order to have an 8x8, right? Most of our mobile devices are 2x2 to transmit, to receive. And so maybe the question is, well, why should I have an 8x8 or even a 4x4 if my devices are 2x2?
Yeah.
Well, when we talk about things like MU-MIMO, you could use different antennas to send data to like a beamforming, like send a signal out a specific antenna towards a specific direction passively, because the antennas aren't an active antenna. It's not changing its internals to like send data, but it's going to try to form a signal towards a general area of where maybe that device would be. So I could send a transmission to you, David, but then somebody else could be sitting on this side, and I could send a transmission there using different antennas. And the thing is, for me, with MU-MIMO or multi-user, multiple input, multiple output, is that it's very hard to really see if that works. Well, it's hard for me to see if that works with the technology I have access to, right? There isn't, say, like a command line where I can go, how well is MU-MIMO working? And also MU-MIMO depends on the spatial diversity of the clients. So if you have 10 clients all clustered together, it's kind of hard to beamform to one of those 10 clients because they're all in the same general direction. And that's where you'll hear a lot of people saying like maybe MU-MIMO doesn't work. But for me, I don't know how to check if it actually works.
I mean, it's very interesting what you said. So just so that I understand, because once again, I'm going to be the guy that is the slowest student in the room. Beamforming is, as you explained it, so you can push a beam this way and a beam that way to try and get better throughput. And then just on this MU-MIMO, there's a difference now, a big difference that I read between this and AC or Wi-Fi 5, isn't there? Something to do with the receiving and the transmitting.
Yeah, so in AC or Wi-Fi 5, it was what they call downlink. So from the AP to the client, you could do MU-MIMO. With 11AX, you can do MU-MIMO in both directions. You could do it downstream and also from the client back to the AP.
So does that mean that, getting back to like your example of, it's not a switch, but it's switch getting closer to switch-like? So that means that the AP can send to multiple clients at the same time, but the multiple clients can send back at the same time. Is that right?
Yeah, it's getting to where it seems like a switch, but it's still half duplex.
Yeah. But the idea is like if you... Sorry, go on.
No, go ahead.
No, I was just going to say, my apologies to everyone. Rawal's in California. I'm in the UK. There's quite a bit of delay on the link, so forgive us for over speaking one another. This is the problem. We're doing wireless here, dude. It's like it's not full duplex. But sorry, you carry on.
I already lost my train of thought there, but
I was going to say, it's not like a switch. It's kind of getting to switch-like where the AP can send at the same time. Sorry, the AP can send to multiple clients at the same time, and the clients can send back at the same time. So did you want to say something about that, or I'm going to push you now?
Yeah, so the caveat there is we always have to remember with Wi-Fi 6 is we're taking one channel and say that's channel 36, and we're dividing that channel into sub-channels, which are very small frequencies. So that's what the devices tune to. They tune to that small frequency, which Wi-Fi 6, it's called resource unit. And so the resource unit is the small channel. And when I say channel, a channel in Wi-Fi is also a frequency. So it's a very small frequency that a device will tune to and transmit or receive on that frequency. And that's how you can get the multiple devices being able to receive or transmit. Because then the AP with its chips and the math can determine, okay, that client is on this sub-channel of channel 36 and that client's on this sub-channel. It coordinates all that. And the resource units, it could expand into different combinations, right? So with resource units, if a device took up the full channel, that's one resource unit, but the full channel, technically that's 242 resource units, and that device can use it all. You can further subdivide that channel into smaller resource units. I'm not going to bore everyone with all the numbers, but let's say there's 2 devices. You can split that channel into 2 sub-channels, and they can transmit and receive at the same time. So that's kind of the logic. It goes further down, and you can have up to like 8 sub-channels.
Yes, I mean, this is quite a change, isn't it? Because in the past, we had like a channel, 20 megahertz, and only I could speak on that, or you could speak on that. But now they're breaking it up into these, did you call it resource units or sub-channel type thing, yeah?
Yeah, in the draft, it's called resource units, but really I like to call it sub-channels because we speak in channels anyways. So that's what it really is.
Yeah, so basically you're taking 20 megahertz and you're splitting it, say, in 2. So you and I both get 10 megahertz. So we can both send at the same time because rather than using the full channel, we're using one of these sub-channels.
Right. Yeah.
But it's still CSMA/A. Sorry, CSMA/CA.
Still collision avoidance because there's still a possibility of collisions that can happen, right? And then one thing I didn't mention before is we still have this transition from Wi-Fi 5 to Wi-Fi 6. So you're going to have a mix of devices, and anything that's not Wi-Fi 6 is not going to be able to take advantage of those Wi-Fi 6 capabilities because you have to be a Wi-Fi 6 device.
Yeah, so all the previous versions of Wi-Fi, they use the full channel. Is that correct?
Yeah. So if you wanted to transmit and I wanted to transmit, I'd have to wait for you. But with I'd have to wait for you to transmit first, and then I can transmit. And then with Wi-Fi 6, the AP can just subdivide the channel, and we can both transmit at the same time. So it's like going to a fast food drive-through, a single lane drive-through.
Yeah.
You had to wait for the guy in front of you to order, but then they came out with 2-lane drive-throughs.
Yeah.
So now you can place 2 orders at the same time. Like they try to make that efficient, that line more efficient, and make you go through the line faster. It's very similar to that.
I mean, that's great. I mean, I can understand the analogy of using a switch because it kind of sounds like that, but not entirely because it's still carrier avoidance within that channel. And if you have an old device broadcasting like crazy on that channel, it's going to affect you.
Exactly. I was saying exactly this is what Wi-Fi 6 is trying to solve, is that density problem, because what I like to tell people about Wi-Fi is you have this pie on the table, right? This delicious looking pie. If you were the only one there at that table, you can have that pie all to yourself. But as soon as somebody else comes, now you got to split that pie maybe in half, right? Depends how hungry you guys are for data. And then the more people come, you get a smaller slice of that pie. That's kind of how Wi-Fi is the more people there are, a small sliver of airtime you're gonna get, right? And because this is the first time I mentioned airtime, because Wi-Fi travels through the air. What we're trying to do is get people to communicate and get off the air faster, right? Transmit your data, get off the air so somebody else can transmit. And so that's what we're trying to make more efficient, is that airtime utilization, that airtime efficiency is what they call it.
I mean, I'm glad you've used that analogy of the pie because, I mean, the problem, I think, with Wi-Fi is we've only got a certain number of channels, haven't we? So, I mean, you mentioned like they're trying to extend the channels. Is that right in Wi-Fi 6? Give more channels? Or?
They're not trying to extend the channels. There's a separate project where I know in the US, I'm not sure about other countries, they're trying to expand the number of another frequency, like the 6 gigahertz frequency for Wi-Fi. And if they did that, we would have a lot more frequency to use and distribute users across different frequencies. So that way everyone can get access to different pies, right? There's more pies available. And that way there's less what's called, this is the first time I'm going to say this, contention. Because if you think in terms of a switch, right? You have a single port, a switch port, and whatever's connected there, that's a single collision domain, right? I'm sure your audience will understand that. Yeah. With a hub, hopefully you guys know what a hub is.
Yeah, the audience is like CCNA level. I think most people know what a hub is. Yeah.
It's just I haven't seen a hub in so long, except for wireless.
I can go and get you one. I've got one upstairs.
But a hub is a single collision domain.
Yep.
That's what Wi-Fi is. It's like a hub. It's a single collision domain. And so when we have different channels, we're trying to create different collision domains, because if you have channel 1 and channel 6, those are 2 collision domains. But if you have an AP on channel 1, let's say here's a room, here's an AP and an AP right here, both on channel 1, that is effectively a single collision domain because they're on the same channel. So what we're trying to do is create multiple collision domains so that we don't run into what's called like co-channel contention, where a lot of devices are contending to use airtime because they're all communicating on the same channel.
So I'm really liking these analogies of the pie and the hub. So let me try and break this down. If you've got 2.4 gigahertz, you've got 5 gigahertz, and then maybe 6 gigahertz. So let's just use 2.4 and 5 at the moment. Is it correct to say that like 2.4 we have a certain number of hubs because each channel, and then in 5 we've got a certain number of hubs each channel. But if you do bonding, it's like joining multiple hubs together. So you've got like more possible collisions if guys are overlapping on those channels.
Right. Except that when you channel bond, that becomes one hub.
Yeah.
And then we just have less channels to use, right? So if you've got, say, a campus environment and a large building, or actually no, what's better to use is like an apartment complex. There's a lot of users there, right? And typically in an apartment complex, Wi-Fi is terrible. And that's because everybody is stepping on each other's on the same channels. There's only so many channels you could use that you have to reuse those channels. And so the more often you have to reuse that channels, the more you'll have contention, because now I'm on channel 36, but so are, the 10 neighbors that are around me. I could all hear their networks. And so when we're all trying to watch Netflix at the same time on the same channel, everyone's got to communicate one at a time, right? You got to send those frames one at a time. And so the more you have on a single channel, the less the smaller slice you have of that pie, and that's what Wi-Fi 6 is trying to solve with the efficiency of how those channels are used.
Yes, it's like breaking the channel up into smaller hubs, if you like, and putting people on smaller little collision domains.
Right. Yeah, because the transmissions are so tiny. We're not usually transmitting large amounts, a large packet size, a large payload size. It's usually very tiny. It's like little GET requests, right, to your website, and that's all you really need. It's not like you're requesting a payload larger than 2,000 bytes usually. So it's usually small, and that's why they wanted to split those channels into smaller subchannels.
Yeah, I mean, that makes a lot of sense. I mean, the data that we're sending is, say, voice over IP or small data sizes, so it makes sense to, rather than have a big channel, break it into smaller channels because everyone's sending smaller packets anyway. So the analogy of like stacking stuff within a truck or a big van or something, yeah?
Yeah, and one of the things with Wi-Fi 6 is the scheduling piece where with OFDMA, when
Yep.
you have everyone transmitting at the same time, that is a single transmit opportunity. So they're all they all contend to transmit, and that's a transmit opportunity, and then they all send their data. So that's like the analogy of the truck being all like you send that truck off, and it's got all that data on there, and then the AP receives it, and it's the same way coming back.
So, I mean, I wanted to ask you about, we were talking about the apartment complex. There's two things here. I wanted to ask you about this coloring thing. So how does that in Wi-Fi 6, can you explain what that is firstly and how does it help?
Yeah, so there's this concept of BSS color, and that BSS is basic service set. And a basic service set is just another name for like your SSID. Your
Yep.
SSID on 2.4 gigahertz, that is a basic service set. It is a separate basic service set if you're broadcasting that same SSID on 5 gigahertz. And so if you just take 2.4 gigahertz as an example, if somebody else is transmitting on channel 1, the same channel you're transmitting, with Wi-Fi 6, you'd be assigned a color. And technically there is no color like blue. It's really just a number. I don't know why they call it color. It's numbers from 1 through 63. And so you could be assigned color ID number 1, and your neighbor also on channel 1 can be ID number 10, for example. So if your device was transmitting and it heard a transmission on channel 1, in the actual, if you look at the frame in one of the fields, it'll say the BSS color. Your device will say, okay, what BSS color is that? That is not my BSS color, so I don't care. So it'll just let it send the data. And part of that technology is that with BSS coloring, it'll help tell devices, hey, turn down your transmit power because you're broadcasting way too high, that it's sending the transmission like way over there to another BSS that's also on the same channel. That's the best way I could put it right now. And the BSS color is really just meant to say, that's not my BSS, so I'm going to transmit anyways, but at a lower transmit power, so I don't transmit on top of their transmission and ruin their signal.
So, I mean, this coloring thing works because, let's say you're talking next door to me and I'm talking. If I see your color, in the past I would have had to back off, but now I don't. Is that right?
Yeah, it gives you kind of a sense for, and it's super technical in the documentation, but it allows you to just transmit without waiting. It just transmit your data, but at a lower transmit power, so that way you don't cause a collision with the other BSS in a different color. But there still is a possibility of collisions. The thing with BSS coloring is I have not ever seen that in action. So I'm very curious how that's going to play out in a high density environment like apartment complexes or dorms.
It's interesting that you said that. I mean, I think it's important that we preface this by saying there's so few devices that support Wi-Fi 6 at the moment that a lot of what we're talking about is pre-standard. Standard's only being ratified at the end of 2019, is that right?
It's supposed to be
sometime
at
this
the
year.
end of 2019. It might go into 2020. No one has said anything yet, but I'm pretty sure it'll be ratified soon.
And have you seen this out in the wild, or is it more like in labs?
It's more in labs. I mean, I have two Wi-Fi 6 access points here, but I have no Wi-Fi 6 devices. I came this close to getting a Samsung S10, but
I saw you tweet about that.
it doesn't help at all because it's a single device, right? When I test this, it's going to look great to me because I'm going to get the best speeds. I'm going to get high data rates. I'm going to see what was advertised by the vendors. But it's a whole different beast when when you bring in multiple devices, like hundreds of those, and have maybe a dorm setting and a apartment complex setting, because that's the environment that the Wi-Fi 6 is catered to, high density, and making that
I mean,
more efficient.
yeah, you said high efficiency. So, I mean, high efficiency isn't going to work very well if you have one device.
Right. There's no efficiency there. I just have full access to that channel.
So, Rawal, reading through some of the documentation about this, I believe there was a big change in Wi-Fi 6 versus Wi-Fi 5 to do with 2.4 versus 5. Is that right?
There isn't like a big change. It's just people are saying 2.4 gigahertz might make a comeback because of the efficiencies that will come to 2.4 gigahertz. That might be the case, but we still have only 3 non-overlapping channels to work with.
But sorry, what I was trying to get to is that in AC, so Wi-Fi 5, 2.4 gigahertz, was it supported or wasn't it supported?
2.4 wasn't part of Wi-Fi 5.
Yeah, so in other words, they're bringing that back in Wi-Fi 6. Is that correct?
Yeah, so in Wi-Fi 6, we're going back to part of this backwards compatibility by supporting 2.4 gigahertz and 5 gigahertz. I think maybe down the road 6 gigahertz might be added to that, but we'll probably see a different wireless standard by then. But with 2.4 gigahertz, we'll see all these same technologies that we've been talking about, your airtime efficiency, BSS coloring, OFDMA, all apply to 2.4 gigahertz as well.
But why did they bring back 2.4? Is it because of the distance? It can go further, that kind of thing? Or what are your thoughts on that?
I think it's more about just having the available frequency, right? Like, why ditch 2.4 when it's still there? If we've been pushing a lot of devices to 5 gigahertz, but why not start using 2.4 gigahertz again if we can still add that efficiency there to 2.4 gigahertz? Most devices are dual band anyways. Dual band meaning they support 2.4 and 5 gigahertz. So it's there. Might as well use it, right? Instead of just avoiding it altogether.
That's a good point. So, I mean, just to summarize for everyone's benefit, big change I think it's a big change is that in Wi-Fi 6 versus Wi-Fi 5, they've now are supporting 2.4 gigahertz channels. Yep. One of the things I saw here is they talk about better latency or lower latency. Can you expand on what does that mean or how does it work?
Yeah, I think the latency is trying to improve latency in a higher density situation because of so many devices trying to gain access to wireless. We tend to see wireless slow down in, say, like a conference type situation where there's so many people. They're all trying to get on Wi-Fi. It's slow. Things aren't loading very, very quickly because of that latency. The latency increases. As latency increases, your throughput decreases. And so with the efficiencies that Wi-Fi 6 is bringing in with the OFDMA, that's, I think, going to lower the latency because of the multiple access that OFDMA brings, and having multiple devices either transmit or receive simultaneously. That way, like what we've talked about before, you're not waiting in line to transmit. You're just able to transmit along with others on just different subchannels. And I think that's what's going to really improve the latency is because of that.
And I mean, another caveat to all of this stuff that we're talking about is, I mean, we were talking about the joke about you trying to get considering getting a Samsung phone, is this, all these cool features only apply to Wi-Fi 6 devices, but it's not like everyone is going to replace all their Wi-Fi 5 devices like that tomorrow, are they?
Yeah, that's absolutely correct. It's going to take a long time to have this transition from Wi-Fi 5 to Wi-Fi 6. I mean, we've seen this in the previous protocols, right? How long did it take to go from 802.11n to 802.11ac? But I think if we rely on some of these big vendors, right, you've got really big vendors now like Samsung and Apple are the biggest two. Samsung being the first to push for this, I think we may see that transition happen faster as people are now upgrading at faster cycles for their mobile devices. Maybe laptops are a different story because those are a much bigger investment, but none of these really aren't going to be taken advantage of until we have all Wi-Fi 6 devices using the wireless network. But that being said, it may be possible to take advantage of that if, say, an access point has a radio dedicated to just Wi-Fi 6.
Yeah, because I wanted to talk about that a bit. Is in the going back, I mean, I'm showing my age here. I remember there was this thing with 802.11b and how it was a major problem. It would slow the entire access point down, and you used that example of the Apple TV. So I'm assuming that you could have these older devices that slow everyone down, or is your example of using a different radio going to try and solve that?
That's an idea that's been floated around, is how to make sure your Wi-Fi 6 devices actually take advantage of Wi-Fi 6 is by putting them on a radio that Wi-Fi 5 and below cannot use. But if most vendors are probably just going to use the same radio, so that's where the analogy of you driving a Ferrari behind a slow car, that's what's going to happen for this transition period, because the AP has to shift from Wi-Fi 6 to then Wi-Fi 5 or even below, right, as it supports older protocols. And we're going to see that change for a couple of years, because it's going to be a while before everything is Wi-Fi 6.
So do you suspect that, like, if people have still got, like, I mean, they're going to have like Wi-Fi 5 devices and perhaps Wi-Fi 4 devices, that's going to inhibit sort of this delivery of all the cool speed and whatever of Wi-Fi 6?
Yep, exactly. Because if an access point supports all of those protocols, right, when it shifts from Wi-Fi 6 to Wi-Fi 5 or Wi-Fi 4, it's not using OFDMA anymore. OFDMA being like the biggest improvement to wireless. It's not going to use that. It's going to use regular OFDM, and that's just one device taking up a whole channel to transmit whatever packet size it's trying to send. And so that, I think, is where people might initially say, well, I don't see a big improvement in Wi-Fi 6. And that's because you have to have Wi-Fi 6 devices.
I mean, so in your experience, I mean, you've been doing this for a long time. How long did it take to go? Because you said it took a long time. But like, in how many years do you reckon it would take based on your experience? I mean, this is obviously no one can hold you to this, but just based on like your experience, how long did it go from N to Wi-Fi 4 to Wi-Fi 5, and how long do you think it's going to take to go to Wi-Fi 6? Sorry,
I think it took at least 3 years to start seeing. I mean, I still see 802.11n devices on my networks, so it's taken a long time, and like at home, we can change that out pretty quickly. But if at the office, like wherever you work, your business or the business you work at, you also got to think about budget cycles, right? So people probably won't be upgrading their access points that quickly if they just upgraded to 11AC. And so you may have a Wi-Fi 6 device, but the venue you're at or the business you're at just hasn't even upgraded their APs to Wi-Fi 6 yet. And so we're going to see that same kind of transition everywhere, is this upgrade cycle and this transition to Wi-Fi 6 is going to take maybe at least 3 years plus, maybe 5 years.
So what are you recommending to your customers? I mean, obviously, if it's NDA stuff, don't say, but like, what would you say if someone's considering buying Wi-Fi today? I mean, Cisco have just released their Wi-Fi 6 products. I mean, it's the time to get Wi-Fi 6 now. Is that right?
It is, yeah. I mean, it's the cost difference between a Wi-Fi 6 AP and a Wi-Fi 5 AP is not even, it's probably a better savings to go with Wi-Fi 6. But let's say someone just upgraded to Wi-Fi 5 APs. I would say you if you have the money, go and upgrade it to Wi-Fi 6 when there's more devices. Or I say hold off, wait for more devices, see what happens. Or if you're at a point where you have to buy access points and you don't upgrade your access points for another 7 years, I'd say just upgrade to Wi-Fi 6 now.
I like that advice because I think it's very practical what you said there. People think about, okay, like today when we're recording this in May 2019, the only client that, I mean, I think you mentioned you found another client, but the only client that I could find was a Samsung phone.
That's correct. There's only, if you want to get something off the shelf, Samsung S10 is the only Wi-Fi 6. I had to go find an internal card from eBay, and I had to open my laptop, my Windows laptop, and screw that card in there. And hopefully, I have drivers that work.
Hopefully. Yes, I mean, it makes sense to upgrade access points today if you're at that point, because
Yeah, if you have a long upgrade cycle, like let's say if you have to upgrade today, but you're going to upgrade in 3 years from now, I'd say just wait. Um, if you can wait to upgrade to Wi-Fi 6, just wait to see what happens as devices roll out. But if you're upgrading today and your upgrade cycle's 5-7 years, just upgrade to Wi-Fi 6, so that, because by that time you'll have Wi-Fi 6 devices coming onto your network.
yes, I mean, so just to summarize, you'll only start seeing the benefits of Wi-Fi 6 once you have clients, and once the older clients have phased out, because the older clients will be slowing down, like your analogy of the Ferrari stuck behind a slow car. The old clients are slowing the new clients down anyway. That's brilliant, Roel. So, I mean, I've been keeping you for an hour. So, do you have any other recommendations or, information about Wi-Fi 6? Because I've asked you a bunch of stuff, but is there anything that I've missed that you want to highlight?
There's one thing that we didn't even talk about because it's really technical, is the modulation, right?
Yeah.
Most people don't know what modulation is used with Wi-Fi, but that also determines, the modulation determines your data rate, your how fast your throughput's going to be, and in Wi-Fi 6 they increase that to what's called 1024 QAM, and realistically, that's been very difficult to achieve a high modulation, because the high modulation gives you the higher data rate, the higher throughput. But that's like taking a bow and arrow and trying to hit a bullseye from across the football field, right? It's got to be that accurate, and you've got to have a clean wireless environment where there's not a lot of noise, not a lot of interference. And that's where also a lot of the speed increase may come, is from 1024 QAM modulation. And that's really just taking frequency and using the amplitude and the phase, and adjusting that to send data at a higher modulation rate.
So just to simplify this, so basically, when you talk about modulation rate, I can put more data on the I would say on the wire, but that's not the right analogy. On the air,
Over
is
the
that
air,
right?
yeah.
Yeah. So in a period of a second, or millisecond or whatever, I can put more data on, because I can modulate more data onto the air in any given time slot. Is that right?
That's right. And you also have to consider that from the transmitter side, it may be modulating it at 1024 QAM, but the receiver has to demodulate that signal. So if that signal is barely readable by the client, it's not going to acknowledge that it received it, which means the transmitter will have to resend that, and that's called a retry, and that's typically, when you have more retries, you have lower throughput.
Yeah, so in theory, if your air is clean, and I don't want to make a bad joke about air being clean, but I mean, like, there's not a lot of noise, not a lot of clients speaking, they could go up to this 1024 QAM. Is that right?
Yeah, I think it should be, it may be fairly possible, because again, we're taking a channel and subdividing it into smaller channels, which having to tune to a smaller channel means your signal to noise ratio is going to be a lot better, because you're not tuning to a larger frequency, you're tuning to a very smaller frequency. And so might be possible to modulate and demodulate at 1024 QAM, but hopefully in a couple weeks I should be able to test that.
Brilliant. So, I mean, just to summarize what that is basically more data can be sent every time cycle, or whatever you want to call it. So modulate more data onto the air, and it goes to 1024 QAM. Previously, what was it, 256 was it, or something?
Yeah, 256 QAM. So it's quite a big jump, and again, it requires a lot of accuracy in hitting that modulations. So we'll see when more devices come out and people actually start testing it and sharing their tests, whether or not we can actually hit that, because it does require what's called a higher SNR, signal to noise ratio.
But in theory, if it's clean, this is where we get this thing about 4 times or whatever. I think it was 4 times was quoted the speed of Wi-Fi 5. Yeah.
Yeah, I think that's where they're getting that number from various aspects, right? Your 8x8, the OFDMA, your modulation scheme. Like they've tested that in the lab and said, yeah, we can get 4 times the better speed with this efficiency.
Well, I've been hearing all this talk about IoT, Internet of Things. There's all these devices. You've got an Alexa in your home that's listening in on what you're saying. Oh, no, sorry, helping you control your devices in your home. You've got like bulbs that, you can talk to. So can you explain, what is Wi-Fi 6 got to do with IoT and why, what is it? Why is it important?
Yeah, Wi-Fi 6 introduces something called target wake time, or TWT, and this is supposed to help devices with improving their power requirements. So there's going to be a lot of IoT devices that are battery powered, for example, or they don't really need to be talking on the wireless network often, but when they do, they need to power up their, use more electronics and basically need to stay alive as long as possible on that battery. And so Wi-Fi, anything prior to Wi-Fi 6 had a different kind of power saving mechanism, but with Wi-Fi 6, it's going to help reduce contention onto the Wi-Fi medium and also reduce the amount of time a client needs to be awake. So there's going to be a schedule that the access point tells all the clients saying, hey, here's a schedule to wake up and transmit and receive data. And that's pretty much all it is. So when the client wakes up, it can just transmit data and then go back to sleep. Only wakes up when it needs to, right? Instead of just having to wake up at these intervals, it knows exactly when it needs to wake up and transmit or receive data.
Yeah, so basically, is it true that the AP could tell that IoT device go to sleep, and not just milliseconds, but go to sleep for a long period of time? Is that right?
There's different ways that it can be done. It can be done from the access point where the devices just listen to what the access point says, and it says, here's how long you're going to sleep for. Wake up at this time. And then a device can also have its individual schedule, and it's going to choose how long it wants to sleep for, and the AP has to keep track of that as well. But those are the 2 main methods, and it's really going to be dependent on how the vendors implement that into their APs and whether or not we actually see this in a lot of APs. So that's a lot of why there's a lot of waiting. We want to see what gets implemented on these access points.
Yes, I mean, just coming back to a point, this stuff is still pre-release. So does Cisco, they've released this access point. Do you know if that supports this?
I'm pretty sure it does. I'd have to look at the data sheets. There might be one AP that doesn't, but I'm pretty sure it supports target wake time.
So, I mean, could the AP or could the device, I mean, however they negotiate, could the device go to sleep for like half an hour or a day or like a week or something? Is it long periods of time?
Yeah, very long periods of time because of these IoT devices, right? They don't need to be on often. And so it could have its own individual target wake time schedule, and it just presents that to the access point. And you could actually see this if you dig deep into the frame captures. You'll see that saying individual target wake time, and the AP can either take that in or say, no, you should follow mine. It's really, again, it just depends on how that's implemented down to the vendor.
Yes, I mean, you were talking about like AC was about speed, but here AX is about efficiency. So I'm assuming this is another type of efficiency. This is like power saving.
Power saving efficiency, so that way your IoT devices have longer battery life. Same thing with mobile devices and even laptops.
Yes, I mean, your mobile phone won't be drained as much because the phone basically turns off the antenna. Is that right?
Yeah, it's not having to go, okay, let me turn them on and see if I have any data waiting for me. It just will go according to a schedule. So it doesn't have to wake up unless it needs to.
Yes, I mean, previously this thing would turn on, have you got data for me? Turn on, have you got data for me? But yet it actually gets told, okay, I can go off for a week and then I'll send data and receive data in a week's time. Is that right?
Yeah, I'm pretty sure that's how it could be done. The draft doesn't specifically mention, hours, days, or weeks, but yeah. I think that could be implemented depending on how the vendor does it.
Yeah, I mean, I think it's. I mean, I'm just pushing you here and poking you, as I said I would do. It's a lot of this stuff still has to be implemented in, as we said, the only device currently that we could find was a Samsung S10 phone. So, I mean, another issue, I suppose, these standards have lots of cool things that people could implement, but a lot of vendors, especially like IoT vendors, won't necessarily implement that to save on money.
Right, yeah, and that's another point. And to save on money, does that mean a Wi-Fi 6 chip is too costly? Does that mean they won't do Wi-Fi 6? They'll stick to Wi-Fi 5 or even 4 because it's cheaper. This is where I tell the community to engage with the vendors you use and try to get them say, hey, why aren't you using Wi-Fi 6 or even at least Wi-Fi 5 on your devices? Because I see a lot of devices that are just old because the manufacturer opted to go cheap on the Wi-Fi card.
Yeah, I mean, that's the point. If you're buying an IoT device, most people just look at cheap, don't they? And that's like a problem with security, and it's going to be a problem with Wi-Fi as well.
Yeah, if you go cheap, you go cheap with Wi-Fi, and you shouldn't be complaining about speeds and performance.
It's a very good point. So, Roel, what else have I missed? Because, I mean, you spoke about QAM being something that I've missed. Is there anything else that you're excited about or like technical stuff that you want to explain to the wider community? What did I miss technically that you think we should know?
Yeah, I mean, I think we covered the all the big pieces of Wi-Fi 6. I think the only thing that I tell people when it comes to implementing Wi-Fi, and this has nothing to do with Wi-Fi 6, is I tell them, especially in enterprises and higher education, different companies that deploy their own wireless, is to make sure you plan and have a design, because just because you have the latest and greatest Wi-Fi doesn't mean it's going to work great if you didn't plan and design for that, right? For the requirements that are needed. And I see this all the time where people just put up access points. They think more is better, and sometimes it's not because of the finite resource we have with frequency. And I'm big on saying, hey, you should design your Wi-Fi networks. There's a lot of tools and applications to do that.
Yeah, I mean, I thought the best way to implement Wi-Fi is to turn the volume like to the highest possible value, like turn the power right up. I'm kidding, of course. But it sounds like that's what a lot of people do. If I shout louder, you'll understand me better.
Well, if you put it this way, if somebody was shouting at you, but they had a megaphone, right, and you were across the football field, you could hear that person. But if you didn't have the megaphone and you were shouting back, they probably couldn't hear you. And so that's an example of an AP with much stronger antennas and radios and transmit power, but your mobile device does not have that same capability. So when it tries to respond back, it might not get there because the AP cannot demodulate that signal because it's too weak of a signal. So that's why sometimes transmitting at the highest power is not necessarily the best thing, because those devices cannot transmit at the same power level.
It's a great analogy. I like that. So what tools, like what are your favorite tools? Because you were mentioning, we need to be able to design our network better. Like what tools, resources? I mean, can you tell us about your website? Tell us a bit more about your podcast. Where can people get information from you? And like you've got a consulting business, tell us a bit about yourself, and then also like tools and utilities that you find useful.
Yeah, for those that want to, if you're technical, I'm pretty sure if you're watching this show, you're technical, and you want to learn the details, the nitty-gritty details, I have a series with my co-host Francois Vergès on cleartosend.net/AX, and that is all the 802.11ax episodes that we've published. And if you want to learn more about Wi-Fi, we have other Wi-Fi specific episodes there, especially when it comes to designing and troubleshooting. So that's a good resource if you guys want to learn more. If someone needs help designing or troubleshooting or configuring, I have my own business, packet6.com, where I focus solely on wireless, and I go out to companies and help them troubleshoot. A lot of times it's troubleshooting because somebody has deployed it in some way and didn't do the planning, and now it's just not working to what they thought it would work, right? They want to see a better investment in that equipment that they bought. Those are the two resources I'd go to. And then if you want to engage with me, I am on Twitter. I tweet a lot, so @Roel Dionisio.
Yeah, I mean, so are you prepared to fly around the world and help people with their Wi-Fi networks?
Occasionally, I do fly across the United States. Haven't had anyone fly me to a different country yet, but I'm open to doing that.
Yeah, so if you want some expert help with your wireless, there you go. Roel, that's fantastic. I mean, I wanted to wrap up, but before I do, I wanted to ask you, okay, so are there any like software utilities or devices that you could recommend, or do you have that on your website?
You'd have to find it on the episode. We do have an episode about tools on cleartosend.net, but I'm
Right.
a Mac user, so I use Wi-Fi Explorer. There's a light version and a paid version. If you're in education, you get a discount on the pro version. There's design software out there. I use Ekahau. There's also IBWave, which works on both of those work on PC. Ekahau will also work on a Mac. I use protocol analyzer, so Wireshark. I'm pretty sure your audience is familiar with Wireshark. You can analyze wireless protocols with Wireshark. I use that in combination with a tool called AirTool, the same guy who makes Wi-Fi Explorer. That turns my MacBook's radio into a mode where it can start sniffing all those frames, and then I can analyze it in Wireshark. And then there's also spectrum analyzers. You could use a Cisco AP to be as a spectrum analyzer, or you could use something like MetaGeek. They have a spectrum analyzer. They also just released a tool where you can just plug it into your iPhone. It's a little box, and it can do some basic spectrum analysis.
Oh, cool. That's brilliant. I mean, I think we got to wrap it up now. You got to go to work. I mean, it's
I do.
I've kept you here a long time. So, Roel, I just want to say thanks so much for explaining this. As I was saying offline, I thought much better just to talk to an expert rather than me try to explain this. So, really appreciate you taking the time, to explain this to all of us.
Yeah, thanks for having me on the show, and it's good to come away from just audio and actually get onto video.
No, it's fantastic. I mean, it's good to see you, here on the channel. So hopefully I can convince you at some point again when this stuff, becomes more common, or at some point to, talk more about wireless. So let me put it this way to the audience, anyone watching, if you want Roel to come back again and explain more about Wi-Fi, if you want him to, dive deep into a topic, please put it in the comments below. But remember to go to his podcast and to his website, Clear to Send, and learn more. Roel, again, thanks so much.
Yeah, thank you.
Wanna shake the ground, wanna break away.